Okay, let's unpack this. For decades, and I mean really for most of our lives, the way we've talked about depression has been shaped by this one very simple idea.
The chemical imbalance theory.
Exactly. The idea that your brain is just running low on a chemical, specifically serotonin or 5-HT. You've probably heard it, maybe from a doctor, maybe you saw it on a TV ad.
It's everywhere. This idea that clinical depression is just a simple deficit.
Hmm.
And it's the whole reason millions of people take SSRIs, right?
Yeah.
The selective serotonin reuptake inhibitors.
It's become the foundational story. But what's so fascinating and what we're getting into today is how that story holds up against, well, the actual science.
And that's the core of our deep dive. The science has been shaky for a long, long time. We're centering this on a huge event in psychiatry, a 2022 systematic umbrella review by Dr. Joanna Moncrief and her team.
An umbrella review, so that's a review of other reviews.
The highest level of evidence, basically.
Yeah.
It synthesizes everything. And their conclusion, in a nutshell, was that the evidence for the low serotonin theory is just not supported. It sent shockwaves through the field.
But that creates this impossible contradiction. If the theory is unsupported, why are SSRIs still the #1 treatment all over the world?
That's the paradox.
And if this wasn't some big secret, why did this specific review cause such an academic firestorm? It feels like we're pulling at a thread that could unravel a lot.
That's exactly our mission today. We're going to move beyond that simple marketing story. We'll look at what really causes depression, the new models that focus on things like stress, neuroplasticity, and even neuroinflammation.
So we're going to trace the history, look at that firestorm of criticism, and then explore what cutting-edge science says is really happening inside the brain.
Exactly. Let's get into it.
So to really get why this 2022 review was such a big deal, we need to go back. Where did this whole idea of a serotonin deficit even come from? It wasn't like someone just measured serotonin in a depressed brain and found it was low.
Well, not at all. It's actually a fascinating story. The whole thing dates back to the 1960s, and it came from a completely different field.
No.
It started with drugs for tuberculosis. Researchers noticed that some of these early compounds, which we now know as monoamine oxidase inhibitors, or MAOIs, had this incredible side effect.
They improve patients' mood.
Dramatically. So they had this drug that worked, and then they had to work backward to figure out why it worked.
Kind of reverse engineering of the brain.
Exactly. They figured out that these MAOIs stop an enzyme from breaking down a class of neurotransmitters called monoamines. That class includes serotonin, but also noradrenaline.
Okay, so then the next generation of drugs, the tricyclics, did something similar.
Right. They also worked by increasing those monoamines just through a different mechanism by blocking their reuptake, so they stay in the synapse longer.
And that leads to the big logical leap.
The big and maybe hasty leap. If drugs that increase these chemicals make people feel better, then depression must be caused by having too little of them in the first place.
The monoamine hypothesis.
That's it in a nutshell. And serotonin quickly became the star of that show. It was just, it was simple, it was easy to explain, and it became the dominant theory for not just depression, but OCD, anxiety, you name it.
It provided a clear target for drug companies, too.
A very clear target. And it completely dominated research for decades. Which brings us back to 2022 and this huge review that gathered up all that science, 6 decades of it, to see if the basic assumption was true.
So tell me about this umbrella review. You said it's the highest level of evidence. How did they approach it?
Well, they looked at 6 key areas of research that were always used to support the serotonin idea. They scoured all the major databases, looking at all the existing systematic reviews and meta-analyses.
They wanted to see if people with depression, before they got any treatment, had any biological sign of low serotonin compared to people who weren't depressed.
That was the core question. Did the evidence actually show a deficit?
So let's go through those areas.
Yeah.
The first one seems like the most obvious place to look, just measuring serotonin in the body. If the tank is low, you should be able to see it. Why?
That would be the logical assumption. So they looked at studies measuring serotonin itself and its main metabolite, 5-HIAA. That's what's left over after serotonin gets used.
They looked in blood plasma, cerebrospinal fluid.
Right. Cerebrospinal fluid is a much better proxy for what's happening in the brain. And the findings, when they pooled all this data together,
What was the result?
it was null. Nothing. The largest meta-analyses found no association, no link at all between depression and the levels of that serotonin metabolite.
And we're not talking about small studies here.
No, not at all. One meta-analysis on 5-HIAA had data from over 1,000 people. Another one looking at plasma serotonin had almost 2,000. And still, no relationship.
Wow. With numbers that big, if there was an effect, you'd expect to see it.
You really would. It's a powerful statement. So the direct chemical evidence wasn't there. The next place they looked was genetics.
The idea that maybe some people are just born with a predisposition to lower serotonin? The SERT gene?
Exactly, the serotonin transporter gene. This gene basically controls how quickly serotonin gets cleared out of the synapse. The theory was that a certain version of this gene, the short allele, was less efficient.
And that would make you more vulnerable to depression, especially if you went through a lot of stress.
Is a very popular theory, perfect gene-environment interaction. It felt very neat, very scientific.
But when they scaled up the research,
The association, it vanished. This is a classic story from the replication crisis in genetics. A lot of early, small studies found these exciting, positive results.
but they turned out to be false positives.
Right. The Moncrief Review focused on the two largest, highest quality genetic studies ever done. We are talking about absolutely monumental numbers.
Give me the scale here.
One was a genetic association study with over 115,000 people. The other was a meta-analysis combining 31 different data sets with over 43,000 participants.
Yeah.
Both of them found zero evidence, no link between that SERT gene and depression, and crucially, no evidence for that gene-stress interaction either. The whole idea it didn't hold up under rigorous testing.
So no chemical deficit in the body, no reliable genetic link. That leaves the experimental studies. Tryptophan depletion, this is the one where they actually try to cause depression by lowering serotonin, right?
Correct. It's the most direct test of the causal link. Tryptophan is the amino acid your body needs to make serotonin. So if you put someone on a special diet without it, their serotonin levels plummet pretty quickly.
So if low serotonin causes depression.
Then doing this to healthy volunteers should reliably make them depressed. It's a really elegant experiment.
And what did the data from all those studies show?
Overwhelmingly negative. The largest meta-analysis with over 500 healthy volunteers found no effect on mood. Temporarily tanking their serotonin did not make them depressed.
No effect at all.
Well, there was one tiny exception. A very small subgroup of people who had a strong family history of depression showed a very weak effect. But it was marginal, Definitely not strong enough to be the explanation for depression in the general population.
Okay, this brings us to a finding in the review that seems completely backward. It suggested that long-term use of antidepressants might actually be linked to lower serotonin levels. How is that possible?
This is one of the most critical and counterintuitive points. It completely challenges the whole deficiency model. One of the meta-analyses they looked at did indeed find an association between long-term antidepressant use and lower concentrations of serotonin in the blood.
But the drug is supposed to increase serotonin. It's doing the opposite of what the label says.
In the long run, yes. And this points to a fundamental concept in pharmacology called compensatory changes, or sometimes oppositional tolerance.
The brain is fighting back, basically.
Precisely. Your brain is a master of maintaining balance, or homeostasis. If you introduce a drug that constantly floods the synapse with a neurotransmitter, the brain says, whoa, this is too much, and it starts to adapt to turn the volume down.
How does it do that? What's the mechanism?
There are a few ways, but the main ones are receptor downregulation, where the cell just physically removes some of the serotonin receptors from its surface.
So there are fewer places for the serotonin to dock.
Exactly. And the other is receptor desensitization, where the receptors that are left just become less sensitive to the signal. Over weeks and months, the whole system becomes less responsive to serotonin. The drug is actually causing a long-term shift in the entire system, not just correcting a problem.
So the review lays out this mountain of evidence saying the original cause and effect theory is wrong, and even that the drug forces this big adaptation in the brain. It's no wonder it caused a firestorm.
The backlash was immediate, and it was fierce. It really focused on the methods of the Moncrief Review itself. It became a fight over what counts as good evidence.
You mentioned a response from a large group of experts.
Yes, a very public response from 36 leading experts, many from King's College London. And they had some very specific critiques.
What was their main issue?
They argued there were inconsistencies in how the evidence was selected and graded. For one, they said an umbrella review is only supposed to synthesize existing reviews, but Moncrief's team included some individual large studies, like those massive genetic ones.
A technical point, but I see what they mean.
Right. They argued it wasn't methodologically pure, but the bigger criticism was about how the studies were graded for quality.
What was the problem there?
The critics said the review arbitrarily labeled certain types of studies as low quality just because they had small sample sizes. This especially hurt experimental studies and, really critically, molecular imaging studies.
The ones that use PET scans to look directly at the brain.
Exactly. PET scans can measure things like serotonin transporters or receptors in a living person's brain. But they're incredibly expensive, complex, and involve radioactive tracers, so you can't ethically do them on thousands of people.
So you're stuck with small sample sizes, maybe a few dozen people.
Right, but they provide this incredibly direct, mechanistic view of the biology. The critics argued that by dismissing these as low quality based on numbers alone, the review threw out some of the most insightful data we have, which skewed the conclusion to be overly negative.
I see the tension. You have these huge population studies that are statistically powerful but maybe indirect, versus these tiny studies that give you a direct biological snapshot but lack the statistical weight.
That's the heart of the debate. The big genetic studies say there's no link in the population, but a small PET study might say, but we do see a difference in transporter function in the brains of these 20 depressed people. The critics believe that if you look at the totality of all evidence, including those small studies, it still points to the serotonin system being involved somehow in the disease process, even if it's not the simple cause we once thought.
Okay, so regardless of that methodological debate, the whole controversy forces us to ask a bigger question. Why did this chemical imbalance story become so incredibly dominant if the science was shaky for decades?
That's the sociological part of the story, and it's fascinating. The data suggests the term wasn't really driven by scientific discovery at all. Its popularity exploded after the introduction of modern SSRIs in the mid-1980s.
Prozac, Zoloft, Paxil.
The blockbuster drugs. The rise of the term chemical imbalance maps almost perfectly onto the rise of direct-to-consumer advertising for these drugs.
I remember those Zoloft ads so clearly. The little sad bouncing blob that gets happy again. That imagery was so powerful.
Incredibly powerful, and the language was explicit. The Zoloft campaign literally said depression is due to a chemical imbalance, and Zoloft works to correct this imbalance.
Which sounds like a definitive scientific fact. But was it? Was that consistent with what the FDA knew or what the official documents said?
No. And that's the key issue. The official FDA prescribing information is much more cautious. It usually says something like, the drug's effect is presumed to be linked to its action on serotonin. It never says it's correcting a proven deficiency.
So the advertising went way beyond the science.
Way beyond. Many argued it was a misleading health claim. But here's the most surprising part, something our sources really dug into. It turns out that all that advertising might not have been the main reason you, as an individual, came to believe it.
What do you mean?
There was a large regression analysis, over 1,200 people trying to figure out where the belief came from. They tested everything: media, ads, school, family.
And the number one source was?
Healthcare providers, doctors, psychiatrists, therapists. That was the only significant predictor of whether someone endorsed the chemical imbalance belief.
Wow. So it wasn't the TV ad, it was the person in the white coat.
Exactly. When a doctor, someone you trust, tells you your brain has a chemical imbalance and this pill will fix it, that message has incredible authority. It becomes your reality.
Which raises all sorts of questions about informed consent.
It absolutely does. It suggests that clinical communication, more than anything else, is what has kept this oversimplified and maybe inaccurate narrative alive for so long.
Which leaves us with this massive paradox. The science doesn't really support the deficiency theory, but the drugs that are based on it. They do work for a lot of people. So if they aren't fixing a deficiency, why are SSRIs still the first thing a doctor prescribes for moderate to severe depression?
To solve that, you have to make a really clear distinction between etiology, what causes the illness, and pharmacological action, what the drug actually does. SSRIs are still prescribed because of two things: demonstrated clinical utility and a much better safety profile than the older drugs.
Let's break down that clinical utility. How effective are they really when you look at the trials?
Well, meta-analyses consistently show they are statistically better than a placebo. The odds ratio is usually around 1.62, which means you're about 62% more likely to see a response with the drug than with a sugar pill.
Which, for someone suffering, is significant.
Absolutely. For people with moderate to severe depression, about 60% will see their symptoms improve. That's a huge number of people getting relief. But the safety part is maybe even more important.
Compared to the older tricyclic antidepressants, the TCAs.
The difference is night and day. TCAs have a much higher risk of serious heart problems, and critically, they're much easier to overdose on fatally. For a doctor, the calculation is simple. The SSRI is effective enough and vastly safer. It's the default choice for a reason.
Okay, let's go back to those tryptophan depletion studies for a minute. We said that lowering serotonin doesn't seem to cause depression in healthy people. But does serotonin play a role in the treatment itself?
This is where it gets really nuanced and interesting. The key is to look at tryptophan depletion studies done on a different group of people. Patients who had already gotten better on an SSRI. They were in remission.
So they were doing well thanks to the drug. What happens when you suddenly take away their serotonin building blocks?
The results were dramatic. They relapsed. Acute depletion of tryptophan caused a rapid return of their depressive symptoms, sometimes in as little as 4 to 6 hours.
Wow, that's fast. And that timing is really specific.
It correlates perfectly with the peak drop in plasma tryptophan. It's a powerful piece of evidence. It suggests that while low serotonin might not have caused the depression in the first place.
Normal serotonin levels are absolutely essential to maintain the recovery once the drug has worked its magic.
Exactly. The drug has pushed the brain into a new, stable state. And that state is completely dependent on having a steady supply of serotonin. If you pull the rug out, the whole system crashes.
And that's the key difference, because you said it doesn't worsen symptoms in people who are currently depressed but not on medication.
Right. And that contrast is the proof. We're not talking about the original cause of the illness. We're talking about the biological state required for therapeutic maintenance. The antidepressant has changed the brain's operating rules.
Okay, so the drugs are statistically better than placebo. But there's this methodological issue with the trials that we have to talk about, right? This idea of unblinding bias.
Yes, this is a major concern, especially with psychiatric drugs. A good clinical trial needs to be double-blind. Neither the patient nor the doctor should know who's getting the real drug and who's getting the placebo.
But with SSRIs, that's really hard to maintain.
It's almost impossible. Because SSRIs have very common, very recognizable side effects that show up right at the beginning of treatment.
What kind of things are we talking about?
Things like agitation, nausea, maybe some tremors, trouble sleeping, or feeling really sedated. They're often mild, but they are a dead giveaway.
So if you're in a trial and you start feeling nauseous and jittery a few days in, you think, I got the real pill.
Precisely. And that knowledge completely shatters the blind. Your expectation that the drug will work, the placebo effect, gets massively amplified. And at the same time, the doctor observing you sees those side effects and might also guess you're on the active drug, which can unconsciously influence how they rate your mood improvement.
So this bias could be inflating the reported effectiveness of the drug.
It almost certainly is. The true pharmacological effect, the benefit that's purely from the drug's chemistry, above and beyond that amplified placebo effect, is probably more modest than the numbers suggest. It doesn't mean the drugs are useless, but it complicates the picture.
Right. And it reinforces that we really need to understand what they're actually doing in the brain if it's not just filling a tank.
And that brings us to the most important observation of all, the time lag.
The fact that they take weeks or even months to work. If it were a simple chemical fix, it should be instant.
That delay is the final nail in the coffin for the simple imbalance theory. It proves that SSRIs are not a simple fix. They are initiating agents. They kick off a series of slow, complex, and ultimately restorative changes in the brain.
So what is the brain doing during those weeks and months? Let's start with what happens right away, the stuff that happens before you feel better.
This is where we get into the cognitive neuropsychological hypothesis. The core idea is that depression isn't just a mood. It's a state of profound negative bias in how you process information.
The depressed brain is basically scanning the world for threats and negative information.
Exactly. It's hypervigilant to negative cues. You remember negative things more easily. It's a self-reinforcing loop of negativity. And what antidepressants seem to do very quickly is start to break that loop.
So they change how you process the world before they change how you feel about it.
Precisely. And this happens within hours or days. We have observable evidence for it.
What kind of evidence? Give me an example.
Well, studies show that even a single dose of an SSRI can change how you perceive emotional faces. You become less likely to identify a face as fearful. Or in attention tests, your focus will shift away from negative words and towards positive words.
So your brain's automatic subconscious filter starts to change. The world literally starts to look less threatening.
Yes, it's like a deep-level attitude adjustment. And we can see it in brain scans. fMRI studies show that after just a week of treatment, the amygdala, the brain's fear center, becomes less reactive to images of fearful faces.
So the drug calms down the brain's alarm system.
It does. And that creates the necessary platform for recovery. Once your brain isn't constantly screaming danger, You can start to engage with the world more positively, and weeks later, your subjective mood begins to lift.
So that's the rapid returning effect. But the long delay still points to something slower, something structural happening. This is the neuroplasticity idea.
Right. The modern view is that MDD is fundamentally a disorder of impaired neuroplasticity. Chronic stress, we now know, can actually cause brain regions like the hippocampus to shrink, to atrophy. The brain loses its ability to adapt and repair itself.
And the weeks and months of SSRI treatment are basically forcing the brain to regrow, to repair that damage.
That's the idea. The drug acts as a constant, gentle signal that activates the brain's own repair systems. It's a long, slow cascade of events.
What's the key molecule in that process?
The main player is a protein called brain-derived neurotrophic factor, or BDNF. You can think of it as like fertilizer for your neurons.
Okay, so how do SSRIs boost this brain fertilizer?
The constant presence of the drug activates a molecular switch inside the neuron called CAEB. And when CAEB is switched on, it tells the cell's nucleus to start making more BDNF.
And more BDNF leads to what?
It leads to synaptogenesis, the physical growth of new connections, new synapses between neurons. It's actual structural repair and rebuilding of the brain circuits. And because that involves building new proteins and physically growing new structures,
it takes time, weeks and months.
Exactly. The drug isn't the repair itself. It's the signal that tells the brain's construction crew to get to work.
This is such a different picture. We've moved from a chemical model to a structural plasticity model. And that leads us to the other huge pillar of modern depression science: inflammation.
Yes. This is a real game changer. We now understand that MDD is deeply linked to a state of chronic, low-grade neuroinflammation.
So depression isn't just in your head, it's also a disorder of the immune system.
In many ways, yes. Stress, especially chronic stress, triggers an inflammatory response.
Right.
And in people who are vulnerable to depression, that inflammatory response can become chronic and dysregulated. It's now thought to be a primary driver of all the other problems, including the impaired plasticity and the neurotransmitter issues.
How does that work? What's the link between stress and inflammation in the brain?
It all revolves around the HPA axis, the body's central stress response system. Normally, when you're stressed, it releases cortisol, which is supposed to act as an anti-inflammatory.
It should put the brakes on the immune response.
It should. But in chronic depression, something goes wrong. You get what's called glucocorticoid receptor resistance. The immune cells basically become deaf to cortisol signal.
So your body is pumping out this anti-inflammatory hormone, but it's not working, so the inflammation just runs wild.
That's the perfect way to put it. You get this runaway inflammatory state with high levels of pro-inflammatory molecules called cytokines circulating in the blood and the brain.
And these cytokines, they're not just passive markers, they actually cause problems.
They're actively harmful to brain function. They disrupt neurotransmitter systems, they block the production of that crucial BDNF we just talked about, and they create a state of oxidative stress. It's a vicious cycle.
Is this inflammation something we can actually see or measure in the brain of someone with depression?
We can. Using PT scans, we can measure a biomarker called the translocator protein, or TSPO. Its levels go way up when the brain's immune cells, the microglia, are activated and inflamed.
So more TSPO means more neuroinflammation.
Exactly. And the studies are stunning. They find that in depressed patients, TSPO levels are increased by as much as 30% in key mood-regulating areas of the brain, like the prefrontal cortex. And the more severe the depression, the higher the TSPO levels.
A 30% increase in inflammation is huge. But there's a finding here that's even more alarming, something I think everyone needs to hear. It's about the duration of the illness.
This is probably the most urgent finding in the entire field. The research found that the single biggest predictor of how much inflammation you have in your brain is the total amount of time you have had untreated depression.
So the longer it goes on, the worse the physical inflammation gets. It's a progressive disease.
It is neuroprogressive. The data show that for every decade the illness goes untreated, the TSPO volume, the inflammation marker, increases by 14 to 18%.
My God, that changes everything. It's not a static condition. It's cumulative biological damage. The clock is literally ticking.
It means the goal of treatment isn't just about feeling better. It's about stopping this progressive inflammatory damage to the brain.
So if the real problem is this toxic mix of inflammation and poor plasticity, then the future has to be about targeting those things directly, right? We need to get past the slow, indirect action of SSRIs.
That's the whole shift in the field. The new thinking is that SSRIs work when they do because they accidentally end up reducing inflammation and promoting plasticity over the long haul. The next generation of treatments is designed to do that on purpose and much faster.
And the most famous example of that is ketamine.
Absolutely. Ketamine has been a revelation. It's an NMDA receptor antagonist, totally different from SSRIs, and it can produce antidepressant effects in as little as 30 minutes.
30 minutes, that's unbelievable. So how does it fit into our new model of inflammation and plasticity?
It's a perfect fit. On the inflammation side, ketamine is a potent, rapid anti-inflammatory.
Yeah.
Within hours of an infusion, you can measure a significant drop in those pro-inflammatory cytokines, like TNF-alpha and IL-6.
So it puts out the fire almost instantly.
Yes. And on the plasticity side, it does something even more remarkable. It directly activates a crucial pathway for cell growth called the mTOR pathway. This, in turn, triggers a rapid surge in BDNF.
The brain fertilizer.
Right. So when an SSRI takes weeks to gently coax the brain into making more BDNF, ketamine basically hits the fast-forward button. It kickstarts synaptogenesis, the growth of new connections, almost immediately.
It's doing in hours what an SSRI takes months to achieve.
Which is powerful evidence that the real key to recovery is that structural repair, not just tweaking chemical levels.
Okay, what about other compounds? There's a lot of talk about cannabinoids and psychedelics. How do they fit in?
They're being investigated for exactly the same reasons. They seem to powerfully modulate both inflammation and plasticity.
Let's start with cannabinoids, THC, CBD.
CBD, in particular, the non-intoxicating part, is a known anti-inflammatory. It reduces those same cytokines we've been talking about. It also seems to activate a specific serotonin receptor, the 5-HT1A receptor, which is known to help promote neuroplasticity.
And what about psychedelics, like psilocybin from mushrooms or ayahuasca? They act on the serotonin system too, but in a very different way.
A very different way. They primarily hit the 5-HT2A receptor, and they seem to induce a kind of reset for the brain. They disrupt the rigid, negative thought loops and create a temporary state of hyperplasticity where the brain can form new connections and reorganize itself.
And is there an anti-inflammatory effect there as well?
There is. A clinical trial with ayahuasca for treatment-resistant depression found that it significantly reduced C-reactive protein, which is a major marker of systemic inflammation. And the more the inflammation dropped, the better the patient's depression scores were.
So it all comes back to the same two mechanisms, putting out the inflammatory fire and rebuilding the brain's connections.
That seems to be the common pathway for all these new rapid-acting treatments. It's a fundamental shift towards a model of biological repair.
We started this deep dive with that simple, almost comforting idea of depression as a low tank of serotonin. But after looking at all this, the failure of the old evidence, the academic debate, and the incredible new science of plasticity and inflammation, it's clear depression is so much more profound than that.
It's a multisystemic disorder. It involves your stress response, your immune system, the very structure of your brain. It's a disease of connectivity and integrity, not just chemistry.
And that means we have to change how we talk about it.
That is the most important takeaway. For doctors, for patients, for everyone, we have to retire the chemical imbalance metaphor. SSRIs are useful tools, but they are system modulators. They facilitate the brain's own slow process of repair. They're not deficiency correctors.
And clarifying that mechanism also means we have to be much more serious about what happens when you stop taking them.
Oh, absolutely. This is critical. Because the drug forces the brain to adapt over a long period, your body develops a physical dependence on it.
Which is not the same as addiction, right?
Not at all. There's no craving or drug-seeking behavior. It just means your central nervous system has physically rewired itself to expect the drug to be there. And stopping it requires an incredibly slow, careful taper.
What happens if you stop too quickly? People talk about brain zaps.
That's a very common one. It's a sensation of an electric shock in your head. But you can also get severe dizziness, nausea, extreme anxiety, insomnia. It can be debilitating. And it's not a relapse of your depression. It's a physical withdrawal syndrome as your nervous system struggles to restabilize.
So the slow taper is about giving the brain time to safely reverse those adaptations.
It's a matter of neurological safety and ethics. Patients have to be warned, and they have to be guided through a taper that can take weeks, or more often months, to complete safely.
This entire conversation has just hammered home how progressive and serious this illness is. And when you connect all this back to that horrifying statistic about the TSPO marker, the inflammation getting worse year after year, it leaves me with one final thought.
It should. Given that we can now measure this neuroprogression, that 14 to 18% increase in inflammation per decade of untreated illness, the single most urgent need in psychiatry is for fast-acting treatments to be accessible to everyone.
Because the weeks or months we wait for an SSRI to kick in is time that the biological damage can continue.
It's time lost. The future has to be treatments like ketamine or the next generation of drugs that can bypass that long delay and start the process of neurobiological repair immediately. For the long-term health of the brain, we don't have time to wait.